In this video, I'm just going to talk you through the R code quite quickly. There are little snippets of code throughout the notes that you can try, and also I'll put this code up on Blackboard as well if you want to use exactly this. Just remember when you're getting started that you need to set your working directory so that your code file, wherever it is, and your data file are both in a sensible location where R can find them, and then you can set your working directory to your source file location. Is probably the best one if you've already opened up your source file, and make sure your data file is close to it. So I've stuck it inside a folder called data. I'm using the read Excel package. If you don't want to or can't install this for some reason, so under tools, install packages, read Excel. Oh, I can't spell. Read Excel, you can install that. If you want to just use it as a CSV, then you'll probably need to open up the time flies data and save it as a CSV file. So we want to know, is there a difference in how we estimate 10 seconds with eyes closed or eyes open? First step is to do a box plot. You can just use the variable names and then tell it what the data is at the end, or you can use this format where you put in your data and the variable name. So often this one is better just because it will code hint for you as you're typing it out. It will say, do you want this one or this one? So if you can't remember what anything is called, this is probably easier. So this is just time estimate split by condition, and there'll be different ways that you can do this. There's always so many different ways to do the same thing, but this is what is working for me right now, so I'm going to leave it in there. And I've put in some labels: X label, Y label, condition, and time estimate. I haven't changed this 1 and 2, so ideally this should be eyes open and eyes closed. So if you want a little job to do, you can get onto Google and search how to change these category labels in R. The next step would be to test for the variances, and we've already got an indication that there might be a problem because we have some outliers for the people who had their eyes closed. I don't know if they fell asleep or drifted off, but they had some very long time estimates. So we can do a test of variances. So this is doing an F test to compare variances. Sometimes it's a little bit hard to tell exactly. There's lots of different F tests because you'll get an F statistic with different tests. I'm thinking this is doing, if you do this by hand using the F test that we did in class where you divide one variance by the other, I think you'll get exactly these numbers. If you use a different software package, you may get a Levine's test or a Bartlett's test or some other test of variances. But just looking at these degrees of freedom, because it has numerator and denominator, I'm guessing it has done the just the ratio of one variance divided by the other. And we've got a very small p-value. So if hopefully everyone's okay with scientific notation. If you're not, then maybe post a question to the forum and I'll give you a link for some extra reading material about scientific notation. But that just basically means shift the decimal point back 7 spots. So if you add sort of 6 zeros in front of that, you'll see that it's a very small p-value. So the null hypothesis is that the variances are the same. The alternative is that they're not the same. We've got very good evidence here that the variances are not equal, which means that we should be running the t-test with the variance equal set to false. And this is the Welch's t-test. So maybe I should write that in, because in other packages it'll be called Welch's t-test. So I'm guessing Welch was a guy. We could look up who he was if we were bored. So Welch's t-test. Oh no, apostrophe or not, does the test belong to him? I guess so. Anyway, time estimate split by condition. We run this. We get our test statistic, our degrees of freedom, and our p-value. The null hypothesis is that there is no difference in the mean estimate. We've got no evidence against that, and so we will conclude that basically it makes no difference whether you've got your eyes open or closed for the average time estimate. However, there is this interesting little fact of the outliers with the eyes closed group, so that might be something that would be interesting to investigate with a different study. So that's the t-test. And we've got a 95% confidence interval for the difference, which does include 0 because the true difference between the groups could be 0. So if you're having any trouble understanding any of this output, do ask your tutor to go through it with you or post on the forum. All right, the next question was, is there any difference in the allocation over the days of the week? We can get it to count up the conditions over the days of the week into a table. So if I run that, we get a little table of eyes open and eyes closed on Monday, Thursday, Tuesday, Wednesday. So might be handy to reorder these if you can work out how to do that in R. Or if you were putting this into a report, you could just manually reorder them and probably save yourself 2 hours of searching around on the internet. If you were doing this test by hand, you would then need to go through and calculate the expected values based on the same proportion on each day of the week. However, R will do that for us when we run the chi-squared test. So if we run the test, we get a test statistic of 2.6851. So if you want to have a go at doing this by hand, you can check that you get this chi-squared value. And you'll notice that the shortcut for the Greek chi is usually just a capital X. That's quite common that you'll see capital X, often with a 2 for the squared, not even as a superscript. So capital X2 for chi-squared. 3 degrees of freedom, rows minus 1 times columns minus 1, and then we have a p-value compared with chi-squared distribution of 3 degrees of freedom, and it's quite a big p-value. So the null hypothesis is that there is no difference in the proportions over the days of the week. There is no association between the condition and the day of the week, or that condition is independent of the day of the week. So there's lots of different ways you can word that null hypothesis. We've got no evidence against it, and therefore we've got no reason to suggest that there might have been a different allocation or bias on one day compared with another. It would be helpful probably if you were communicating these results to do some kind of bar chart. So you could have a play around with the formatting for this. I've put a link into the R graph gallery where it gives you some different commands that you can use when you're using a bar chart. But the main thing is you have to have the data counted up. You can't just give it the raw data. As far as I know, you may be able to find a different way to do it. So when I created this table here, I saved it into the variable allocation. You could call it whatever you like. And then that means I can use that table to create the bar plot. And if you are doing this for your project, you might just have to have a play around with creating the table in different ways to work out which way makes more sense for showing your data. I think in this case, it makes the most sense to have the days of the week on the x-axis here, and then the eyes open, eyes closed, which hopefully there is a legend somewhere. Is there a legend? Okay, that's the first thing to add to this, is we need some kind of key to understand what these shaded values mean. You could do it the other way around, eyes open, eyes closed, then split by the day of the week, but then that would be 5 categories to read, or four categories to read stacked, which is very confusing. So I think this is the best way for this data, but you might find it the other way around is better for whatever your data is, if you need it for your project, and not everyone will. Okay, so this code file will be up on Blackboard, and there's little snippets of additional code in the notes, and obviously you can just Google anything you want to do and you'll find approximately 10 million tutorials on using R online. Okay, good luck.